So, a very good morning to one and all present here. I, Abhishek Singh Verma, on behalf of Sarda University, welcome you all on this 7th keynote session of 4th one-week International Faculty Development Program on recent advances in computer science and allied domain 2022. I hope you have enjoyed the sessions delivered so far. Today we have with us Professor Neeraj Kumar from Thapar Institute of Engineering and Technology, India. Professor Neeraj Kumar is a senior member of IEEE and highly cited researchers from Web of Sciences in 2019, 20, and 21. He is working as a full professor in the Department of Computer Science Engineering, Thapar Institute of Engineering Technology, Patiala, Punjab, India. He is also adjunct professor at East University, Taiwan, King Abdul Aziz University, Jeddah, Saudi Arabia, and Newcastle University, UK. He has 500 technical research papers in top cited journals and conferences, which are cited more than 29,000 times from well-known researchers across the globe, with current H index is 93. His broad research area are green computing and network management, IoT, big data analytics, deep learning, and cybersecurity. He has also edited 10 books with international and national publishers like IET, Springer, Elsevier, CRC, and many more. He is serving as editors of ACM Computing Survey, IEEE Transactions on Sustainable Computing, IEEE TNSM, IEEE Network Magazine, Elsevier Computer Communication, Wiley, International Journal of Communication, special issues of journals of repute from IEEE, Elsevier, and Springer. He is also TPC chair and member for various international conferences such as IEEE MAS 2020, IEEE MSN 2020. He has won the Best Papers Award from IEEE System Journal in 2018, 2020, and IEEE 2018, and Elsevier JNCA in 2021. He has received the Outstanding Leadership Award from IEEE TrustCom in 2021. Moreover, he received the Best Researcher Award from Parent Organization every year from last 8 consecutive years. With these words, may I now request Professor Neeraj Kumar to take over and address the gathering.
Okay, a very good morning to all of you. So first of all, I would like to thank organizer of this workshop to provide me this opportunity to share my views on one of the most emerging technologies of the modern era, that is called as blockchain technology. So keeping in view of the diversity and keeping in view of the background of all the recipients and attendees, so I keep this lecture as a simple keeping in view that we should know the basic nuts and bolts of how this blockchain technology has been revolutionized like anything in the past years, and how we can use blockchain technology in the modern era for solving various our day-to-day life applications. So basically, contents for today's presentation is all about, first of all, basic components of blockchain would be there that would be discussed, and then overall structure of blockchain, and one of the most important part is as far as the blockchain technology is concerned is consensus algorithm, and how these consensus algorithm had been used for verification and validations of transactions in different applications like financial applications or transport applications or different types of economics related applications. So nowadays we are living in this type of scenario where we have different communities, like we have e-banking, we have different offices of a company across different geographical locations, and we may have other communities, and all of these communities are basically connected with each other. So broadly, in broad sense, we can say that we are living in the connected communities. So these connected communities may be from different locations, and all of these connected communities are connected by some means, by some I mean to say by some purpose, and one of those purposes doing the business or wealth creation. So let's say I'm giving a very simple example that let's say we have a company, that company consisting of different offices which are located across different geographical regions, and these are doing B2B or B2C business, and then all of them are doing this type of business by sitting from remote locations and sharing their wealth or sharing their data across different geographical regions through the internet itself. So you see that if we talk about this type of scenario, so this type of scenario is all about uh, uh, making some sort of business using internet connectivity, and internet is one of the basic, we can say, backbone pillar with which the wealth, or we can say some assets, can be transferred or some assets can be shared across different geographical regions. So in this type of connected communities, uh, one of the most, we can say, challenging issue is that how we can preserve the security and privacy. And obviously security and privacy is one of the prime concern as far as the open networks, that is internet, is concerned. So that's why we can say that blockchain in this scenario can be revolutionized like anything, because using blockchain technology we can manage all of these issues, keeping in view of the scalability of the networks and keeping in view of the information which is being shared among different communities across different geographical regions. So this will lay down the foundation of the revolution of this blockchain technology. So most common part is that in this community, connected community, we have certain participants. Obviously participants are the users who are interested in doing the business and who are interested in sharing their wealth across different geographical regions. And then the second participant is that obviously these participants make some sort of transactions, and these transactions may be some financial transactions, they maybe have some asset transfer, they may have some, I mean to say here, some simple transactions, some commodity transfers, something like that. And we have some sort of contract that will bind that how these transactions must be executed. So for example, let's say we are doing some sort of asset transfer using, let's say, one of the most popular website that is called as car24. So in this car24, if I am the genuine buyer, so I will be interested in knowing that who is the first party of this car which I am going to buy it out, and what is the chain of service record of this car, or is there any issue, or we can say accident history of this car, etc., etc. So I am interested in several types of parameters, and these several types of parameters uh, may be verified before I actually buy this particular car. So obviously I need to trace out all those transactions that had been associated with this car, whether those transactions are associated for service record history, or whether who is this first owner, who is the last owner, and what is the made of this car, and what is the overall structure of this particular car itself. So I mean to say here, if I'm interested in finding out the history of all those transactions which had been committed for this particular car, so my intention is to verify those transactions by sitting on my laptop or by sitting my PC. I can verify those transactions without moving to a particular office. Otherwise, what will happen that, let's say I buy a car from Delhi, so I have to move to Delhi RTO office and then verify each and every aspect or each and every parameters associated for transactions which has been committed for this particular car, which is not a viable option. So better option would be that if I'm sitting in Patiala, so from sitting in Patiala, I should be able to verify all the history or track record of that particular car. So this is one of the, we can say, indicative use cases or indicative applications where we can verify and validate those transactions history, and when those transactions had been committed, along with who has committed those transactions. This is also one of the crucial issues. So I need to verify the identity of the transactions, identity of the person who has made those transactions, and timestamp of the transaction, that when that transaction has been committed, along with uh, the history of all those transactions which had been committed, whether those financial transactions or whether those transactions are simple transaction. So we can say, using this blockchain technology, we can verify all these aspects or all these attributes by sitting across different geographical regions. So there is no need to go to an individual RTO office. So that's why you can see this technology has been revolutionized like anything in the past year. And obviously, if I have to buy car from a particular person, so there is some sort of contract that is to be signed it out, and that contract lays down the foundation of terms and conditions, and those terms and conditions may be in terms of financial transactions, or those terms and conditions are based upon some we can say association associated between different parties. So that's why this will lay down the foundation of that. Within this connected era, we should be aware of who's the participants in the transaction which had been committed, and when those transactions had been committed, and what is the contract that is binding the different participants in a particular organization. So with this simple background, you see, we will go back down to the origin, that from where this blockchain technology has been revolutionized. So back in, we will go just 20 years back. So you can see, back in 2000 there was a financial crisis where we have uh, uh, association with respect to dependency on each individual centralized server. So you can see that if we consider a scenario where different parties are involved for making out some sort of transactions, so this consisting of dependency between different parties. So like for example, let's say we have a party A record, party B record, and then these records needs to be verified and audited. So there is some auditor associated who will verifies the track record of all those transactions which has been committed by this auditors, and along with this some bank records is also there. So now you can see that whole of these transactions needs to be verified by the centralized authority. So this is a, we can say, centralized authority. So this centralized authority is the overall responsibility for managing the assets between different parties, and along with this, auditor also will check it out these transactions records along with the bank records from this centralized entity. But now you can imagine that if this centralized authority may break down at certain instance of time, or it may be shut down due to some error, maybe due to some breakdown. So what will happen? This whole system will be crash in that particular scenario, and these parties which are associated with this scenario may not be able to retrieve the data element, or may not be able to make decisions in this particular scenario. So this means to say that whole system may be collapsed. So what is the solution for this? So the better solution would be this, that instead of going for a centralized entity, we should be able to move to this distributed scenario. So in this distributed scenario, you can see that each of these party maintain their own ledger. So ledger in the sense that they maintain their own records. And but question here arises is that if each of these individual party make their own records, then who will verify those records? How these records will be verified, and how we will keep track of this record? So answer to this question is that with the help of voting mechanism, or with the help of some other consensus algorithm, these parties validate their transactions or ledgers which are digitally signed in the form of encrypted transactions with the help of some mechanism, and that mechanism is with the help of which is called as some sort of consensus algorithm. So there are different consensus algorithm. Obviously each of these consensus algorithms having their own way of working, and they have their own I mean to say criteria using which these consensus algorithm verified and validate the transaction which are supposed to become as a part of the blockchain. So in nutshell, we can say, we can say that instead of having fully dependency on this centralized architecture, now we move to a new system or paradigm shift in which this centralized system has been replaced by a completely distributed system. And there are several, we can say, issues and challenges, keeping in view that we are making a transition from traditional centralized architecture to a fully distributed architecture. And in this scenario, there are a lot of, we can say, challenges and constraints, and these challenges and constraints form the basis of some sort of research issues, which all of us are working in a different directions, keeping in view of different applications and requirements, that how we can design a efficient blockchain solution for food security, how we can design an efficient blockchain solutions for smart transportation system, how we can design a smart blockchain system for financial transactions, asset managements, to name any applications. All of those are in some or other way, we require some sort of access control or authentication mechanism, and those access control and authentication mechanisms we should be aware of with respect to their dependency on centralized architecture. So now most of these solutions which are now centralized, based upon centralized architecture, has now been moved to the fully distributed system. That's why you can see that nowadays there are two verticals in computer science domain as far as my knowledge is concerned. So one is towards this data science, and second is towards this cyber security. So that's why there has been so much boom with respect to the employability and jobs in these two broad area, and that's why in my view computer science graduates has a lot of work to do. So if any one of the graduates has expertise in data science or cyber security, then I think he has a better job employability. So that is the other aspect. So I'm giving a basic understanding that why this technology has been revolutionized and why there has been amalgamation of both these technologies for the revolutionize of different applications. So now with these small foundations, let's see that why what are the basic benefits of using of blockchain technology. So as I have already told you that it will reduce the cost and complexity. So you can see the if we have to make an asset or we have to make a traceability of the assets, so how troublesome it had been if we have to move to RTO, different RTO office to verify and validate the records of each asset, like car, simple, let's say one object is car. So instead of going to different RTO office, it will be a troublesome process, and then it will also have a complex procedure to follow. We have to fill up a lot of forms and then verify and validate, and then have to go individual person. So all of these can be done by sitting at your home and verify and validate those transactions, and then validate those transactions using transaction history. And also you will be able to identify that who has committed those transactions with the help of digital identity of an individual person. And also you can trace out the traceability or time at which those transactions has been committed. So it means to say that it will reduce the overall cost and complexity of the transactions if we are going to use the blockchain technology. Then obviously it will improve the traceability, as I have already discussed, that it is we can fully trace out the transactions when those transactions has been committed, and because it consisting of timestamp associated for each transactions, and we will be able to verify and validate the transaction history using blockchain technology. And the third benefit is trusted record keeping mechanism. So you can see that blockchain technology is found to be secure. So most of the times question in our minds comes is why this blockchain technology is found to be secure. So in the coming slides, I will illustrate you with the help of example that why the security mechanism has been foolproof, keeping in view of the blockchain technology. So, but for the time being, keep in mind that it is a trusted blockchain. It's a trusted networks on which if we have make a small change, even in replacing only a single bit, then a whole we can say algorithm need to be replaced it out, and we have to start from the initial. So that's why it's very almost impossible part for the attackers to attack on the blockchain networks, although some attacks has been happened, but those have not been in mass like centralized architecture. So again, apart from this, we have some shared trusted processes is also there, so we can share the information. So those are some sort of indicative benefits. So those indicative benefits are used to provide information to the end users for keeping the blockchain records in a secure and efficient manner. So now you can see, as I have already told, that earlier in the centralized architecture, we have all those transactions has to be committed those through a centralized node or centralized architecture. So everything has to go to this centralized entity, and he will decide that to whom those transactions has to be committed it out. But now you can see in each of these individual node maintain their own records. So these records are generally called as in the form of a ledger. So ledger is nothing but it is just like a record keeping mechanism. So it is just like a file structure that we are maintaining different ledgers which are should be synchronized with respect to the transactions which had been committed by these end users. So each individual end users maintain their own ledger. So this is just like a peer-to-peer type of we can say networks, where we have the nodes which are maintaining their own records, and they are verifying and validate those records by some mechanism using the consensus algorithm. So all those attributes which are associated with the centralized architecture is now being replaced by fully complete distributed architecture, distributed networks or architecture, which will be consisting of verification and validation of those transactions. So similarly, let's say some company wants to clear out its bill settlement or stock settlements. So earlier it has happens to be this centralized architecture, but now you can see this can be managed with the help of completely distributed architecture, with the help of complete asset managements, where we have different stakeholders maintaining their own records for verification and validation purpose, and all of them are interconnected through some networks itself. So now we come to the basic definitions of blockchain. So if I have to give a basic definition of a blockchain, so it is, I will segregate this name as into two parts. So one is block, second is chain. So it is nothing but it's a chain of blocks. So this is the chain in which blocks are interconnected with each others. But the beauty of this chain is that each of these blocks are interconnected with each others, and they have some attributes associated with each others. So those who are from computer science background, so they already know that how this emphasis of this chain is there. So this is come from the data structure they have already studied. So it is where we have the concept of linked list. So it is nothing but it is just like a linked list. So linked list is just a connection of the nodes. So here I am assuming those as some sort of nodes. So these nodes are consisting of some sort of attributes. So those attributes may be consisting of some data elements, and those are consisting of some cryptographic hash functions. So all of those are having some attribute associated or code associated with them. So these blocks, when these are connected just like a chain like structure, so they have some inherent property with them. So those inherent properties are form the basis of the security of any blockchain network. So you can see that there is some hash value. So first of all, we should go to the hash part, that is what is hash algorithm. So in data structure or other computer science background students, so they already know that, let's say we have some string which is some infinite length string, and when we pass it to some hash algorithm, so we have some code associated with that. So let's say this code is associated when we have some hash algorithm through which some string has been passed it out. So this code is associated after we have some string which is to be mined it out, or which string which passed through this hash algorithm. So now this code is one of those attribute for which is associated for each of these block, right? So this hash value is associated for each block. But the beauty here is that the hash value of this code of this block is one of those attribute of this block. Similarly, hash value of this block that is associated as one of these attribute for the previous block. So now you can see that each of these blocks are interconnected with each other, keeping in view that hash value of one of those previous block is one of those attribute of the uh, previous block associated in that particular scenario. So you can see that previous hash value is one of those attribute. Here again, this previous hash value is one of those attribute, right? So in this way, these blocks are interconnected with each other. So that's why we name these as chain of blocks which are interconnect or interlinked with hash value of the previous block. But which hash algorithm has been used at here? So here in blockchain, we are broadly use, obviously different hash algorithms are there, but broadly for the sake of example, SHA-256 algorithm has been used for mining this string. So here we have, when we mine a string with SHA-256 algorithm, so we got a 64 byte hexadecimal code, and that is called as a hash value for that particular block. Now we come to this part, that this is a hexadecimal code that is associated after we execute an hash algorithm, and after we pass a string to this hash algorithm SHA-256. So there is a code associated that we get after passing a string to this hash algorithm, and we associated as one of those attribute associated as a part of this block, right? So now, keeping on extension of this simple mechanism, that why this blockchain information is found to be secure, we go to the next part, which says that hash algorithm has certain inherent property which needs to be followed it out. So first property of this hash algorithm which we are going to use is that hash algorithm is based upon avalanche effect. So this is based upon avalanche effect, right? So what is this avalanche effect? So avalanche effect is, let's say we have some information. So let's say this NWRAJ, right? So my name is there, right? So it obviously has some code. So let's say this code is like this one, right? And when we pass this information to SHA-256 bit algorithm, right? So we have some code associated for this. So let's say this code is there. So obviously this is a hexadecimal code, right? So I am keeping this as information which is to be shared among different nodes. So what is that? So let's say some attack has been happened on this information, and attackers has changed this E to, let's say, L. So now this become NLERAJ, right? So obviously when we pass this NLREJ, obviously it must have some different code. So let's say I make it as 1010, something like that. So now we have a different, we can say, information which will vary in one bit of information or one character of information, and attackers has attacked some attack on this, and he has changed this information either using code scripting or we can say some other attack that had been led, irrespective of what type of attack those attacker has generated. So we have completely new hash value. We have completely new hash value, right? So we have completely new hash value. So now if let's say this information of this block has been changed, so we will get a complete new hash value, and this hash value will not match with this hash value. So in this scenario, what will happen, that attacker has attacked on block number 2. So subsequently he has to change this value also, he has to change this value also, and subsequently from block number 2 to, let's say we have 1000 nodes in the block, So block number 2 to block 1000, he has to change at the same instance of time all of these hash value, which is practically impossible for the attacker in a particular instance of time, because it must be synchronized with the all the blocks or all the nodes, that they should kept the same ledger, or they should have the same information associated with that. So this avalanche effect will protect the blockchain to be compromised by different attackers. And that's the beauty of this we can say technology, that even if you change, or even if attacker has changed a single bit of information, so we will get a completely new hash value. And if attacker has to compromise the whole networks, then he or she has to compromise all these blocks simultaneously at a single instance of time, which is practically impossible. So that's why using this avalanche effect, we can say this blockchain or blockchain is resilient with respect to various types of attacks. So I hope you got this answer to this question, that why we are shouting, or why we are saying that blockchain technology is found to be secure with respect to different types of attack, or why this blockchain technology has been I mean to say here, resilient to various types of attacks. So this is only because of this avalanche effect. So avalanche effect will give we can say affect, or will provides the resilience of this blockchain technology from different types of attacks in a blockchain networks. So this is one of those core concepts that that this particular blockchain technology is revolutionized like anything. So it is nothing but as we have already discussed, this is a cryptographic chain linking mechanism using which data is tamper proof, and data is tamper proof using the avalanche effect. So that's why even if the attacker has changed a single bit of information, we will get a completely new hash value, and that hash value would not tally or match with the previous hash value. So that's why this blockchain we can say networks is found to be secure. So you can see that if we have a chain of blocks, so its chain of blocks has been replicated to all the nodes at the same instance of time. So you can see it should be synchronized. It should be synchronized in the sense that it should have the same value for all the blocks associated. So if we have a new blocks added in the blockchain network, so at the same instance of time we are growing the size of the chain, so this should be replicated to all the nodes at the same instance of time, so that we have synchronization among the chain size, or among the number of blocks which are part and parcels of the replication part of each and every nodes which is containing the different blocks in the chain itself, right? So so now you can see that this is the generalized we can say peer-to-peer type of network scenario, where we have these nodes which are connected with each others. Nodes, I mean to say, whether you are working on GPU, CPU, or any other parts, or your mobile devices, it should be a part of blockchain networks, but obviously it should have some verification and validation part before it actually becomes part of the blockchain networks, right? So now I'm giving you a very simple example that what are the various basic we can say steps how this blockchain technology or how these transactions has been committed. So let's say I have to transfer some finite number of coin to an individual person. So obviously I have to make some request for the transactions to be executed. So that request should be broadcasted on this blockchain network. So this is nothing but this is a blockchain existing blockchain network. So I broadcast this request on this blockchain network. So obviously this request will go to each individual nodes in the blockchain networks, and then you can see that by some consensus algorithm uh, these transactions which has been initiated by me needs to be verified. So if these transactions may be a bogus transactions, this transaction may be a valid transaction, but who will decide that whether this transaction is a valid or invalid transaction? So this needs to be decided by the consensus algorithm. So consensus I mean to say here is nothing but it is all about agreement. So agreement, I mean to say here that if all of these nodes have some agreement that this transaction should be a part of the blockchains, and they will verify these transactions. And once those transactions had been verified using some consensus algorithm, then these transactions would be executed in a block or in a, we can say, group, and then these group will become as a part of this block, and this block will be added at the end of the chain. So now you can see that this is the existing chain, but after verification and validations, or after the consensus among all these nodes which are part of the blockchain, we have a new block which is to be added at the end of the chain, and the size of the chain is goes on increasing. So it means to say the transaction which has been committed, or the transaction which has been initiated by me, has been verified and validated by different stakeholders or different parties in the networks. And then once those transactions has been committed, so these are passed, verified and validated by different parties, and then finally these transactions get executed. So this is just like we are scanning this QR code, right? So where we have public private key association, and this is called as a PKI infrastructure, which is used to provide public private key agreement between different parties holders. So in background, we have different cryptographic algorithms which are used to verified and validated, that we will illustrate in the coming slide, that how these transactions are get executed using hash algorithms, or we have some Merkle hash tree algorithm or some other algorithms which are used to verify those transactions. So that is a different part that we will discuss in the next slide. So now you can see that as a new blocks has been added, so size of this chain will go on increasing, and we have new blocks added at the end of the chain, and size of this chain is going on. But keep in mind that these blocks which are supposed to become as a part of the chain, they needs to be verified and validated by the consensus algorithm by different nodes. So curiosity in our mind comes is that what should be the structure of the block, and what should be the attributes of the block, what exactly the blocks is there. So is it a data structure? Yes, obviously it must have some attributes. So some attributes is it should have some version information, it should have some nonce. So nonce is time variant codes which obviously keep track of that how which verification and validations of the transactions must be there. So these nonces are time variant codes, I would say, and these are basically used by the miners to mine this block. And previous hash value of the block, right? We have timestamp associated, that when those transactions has been committed, then we have some Merkle hash tree algorithm which are used to verify and validate the transactions, and then transactions list that what which are the transactions which has been committed by those users. So this is just like a we can say structure of this block, and these blocks are, you can see that these blocks are interconnected with each other using hash algorithm. So this is the basic architecture of any block that is supposed to become as a part of the block. But question here arises is that can we increase the number of parameters in this block, and how we can make a program? So obviously you can make a program of your own depending upon which type of application you are dealing with. So based upon those, these attributes will vary. So those attributes, that what type of transactions you are need to commit it, whether those are financial transactions, whether those are simple transactions. So those you can write down those codes of smart contract in one of those popular language that is called as Solidity. So Solidity is the programming language which is broadly used to design your own smart contract for different applications. And these smart contracts are self-executable program, and this Solidity is a language which has been we can say a mixture of C, C++, and JavaScript. So all those programming construct that we are aware of is also applicable for Solidity. Like we can define our own smart contract, we can define functions, we can define variables, and we can define structures, loop, etc. But obviously the structure and defining or writing down the smart contract will be vary from different applications to applications. So there are four basic key concepts of blockchain. So first one we have already discussed is that it has a distributed shared ledger which is shared among different entities. And second part is that it consisting of cryptographic primitives. So as I have already told you that it consisting of SHA-256 algorithm which is used for defining or using the hashing of the input string. And apart from this, we are also using PKI infrastructure, public private key infrastructure, which is used for digital signature identification. So digital signature identification are used for I mean to say identification of individual who has made certain transactions or who has made the transaction at a particular instance of time. So those are some sort of basic cryptographic primitives which are being used on broadly in different consensus algorithm on the blockchain networks. And then smart contracts. So contract comes again with the help of a simple part that is nothing but agreement. And when we say it is a smart contract, so it means to say that agreement is self executable. So it means to say that it is trigger driven. So trigger driven is that let's say it is based upon some auto executable mode. So it means to say that you lay down some triggers, you lay down some conditions. So as soon as those condition has been met it out, so those programs will automatically get executed, and then you will get the final result. So that's why, and these are called smart contracts or agreements. So these smart contracts or agreements lay down the foundations in the self-executable modes. And then the fourth component is consensus. So consensus is the heart of any blockchain network. So you can see consensus is nothing but it's again that we should have some vote in the favor of executable instructions, or we should have some we can say negative sense for, or we can say have some negotiation for not executing that instruction. So those are some sort of I mean to say here let's say we have vote to execute our transactions, or we may have not vote in executable those transactions. So those are some sort of we can say basic postulates of any blockchain networks. And whenever we are doing blockchain for businesses, so most important part is that it should have some shared ledgers, it should have smart contract for validation and verifications, and it should also maintain privacy of different transactions as a part and parcels of those transactions, right? So there are two basic platform that had been used in the past for blockchain maintenance. One is Bitcoin, second is Ethereum, and you can see the difference between these two. And one is basically revolutionized in 2008 and in 2015, and obviously different hash algorithm has been used. SHA-256 here we have ET hash has been used, and here we have the consensus algorithm is POW is used. Here we are using proof of stake. So different types of we can say similarity and differences are there, and these similarity and differences make them popular, keeping in view that they have different they are being used in different applications. So here we have mining times is 10 minutes. So mining, I mean to say here that after every 10 minutes new block has been added, but here it's a very quick, so within 12 to 14 second new blocks has been added. But nowadays we have different uh, distributed ledger technology is also going on, which is primarily used for IoT applications, where we did not require so much time for verification and validations of different transactions. So in that scenario, these transactions can be committed with less time. So you can see that these transactions can be committed in some finite interval of time. So if we have to make certain form of distinction that how we can make a blockchain using database, how we can make a distinction between database and blockchain. So you can see as far as database are concerned, so database have administrations and centralized control, but it is fully distributed architecture. So you can see that no one is in charge or admin in these blockchain networks. So here only finite number of entities having a right who can access the database. But here, if it is a public blockchain networks, then anyone can access this public blockchain. But it is, if it is a private blockchain, then obviously certain restrictions must be there. But here certain entities on read and write operations can be performed. But here we have anyone who has a proof of work can work on blockchain. It is slow because number of nodes are very large, and verification and validations of those transactions may take some time. But here databases are fast, and here no history of records or ownership of digital records has been maintained. But here history of records and ownership of digital records has been maintained. So uh, the basic way of writing some sort of piece of code on the blockchain is to write down the smart contracts or smart contracts. So contract, as I already told you, that it is nothing but it is some sort of agreement between two parties. And earlier what happens is that we are going to write down the contract on the simple piece of paper on using pen and paper, and it needs to be get executed, and then we get executed by some attestation authority. But nowadays you can see that this whole process has been controlled with the help of writing down a piece of code on a Solidity programming language, and that Solidity programming language piece of code is self-executable mode. So it means to say that it must have some triggers. So those triggers will automatically get executed and automatically get executed. So let's say we are using on Ethereum platform. So those Ethereum smart contracts will automatically get executed. So it means to say that these smart contracts are basically a software program which are on distributed ledgers that will allow immutability, verification, and validations, and they are fast in process. So that's why most of the businesses on physical contract has now been shifted to this smart contract. So, and that's why we are saying that earlier with the help of this centralized entity, now we are moving towards this fully distributed architecture. So in this way you can write down the smart contract. So I will not emphasize more time on this. And we can compile and execute those smart contracts written in Solidity programming language using one of this remix IDE, where we can write down the codes, piece of codes, and we can set out the variables on the left hand side, and it if some sort of we can say executable output we need to see it out. So this can be seen on this window itself. So this is the indicative parts of using smart contracts that had been written in Solidity. And we can write down these smart contracts here, and then set out the parameters at here, deploy those smart contracts, and finally we get out some results whether those smart contracts will be successfully get executed or not on the Ethereum platform. So we can say one of those problem that is associated in the blockchain is that how we will mine a particular block. But first of all, we should be aware of what does it mean by the mining. So mining is nothing but it is as I have already told you, that what should be the appropriate hash value using which we will be able to decide that whether those transactions are valid transactions or not. So you can see that if I have some data elements and I pass it to some hash algorithm, then we have some code associated with that. So there are a number of transactions associated for corresponding to which we have different codes. So let's say we have these codes C1, C2, C3 up to let's say Cn codes are there. So we need to set out the certain thresholds. So let's say we have set out this threshold that the codes which are having a value above these thresholds are having comes from the transactions which are valid transactions, and codes which are below this threshold value, those are called as invalid transactions. But question here arises is that who will decide this bar, that what should be the appropriate hash value, or what should be the appropriate we can say threshold using which we can say that these transactions are valid transactions and these transactions are not valid transactions. So that is the game of this task of these miners, that they should be able to decide, or they should be able to decide, or they should be able to mine this block in such a manner that these we can say transactions which are mined, their corresponding hash value should be above this threshold value. And for that particular part we will adjust this nonce value, and this nonce value is some sort of a randomized we can say value, using which we keep on trying that what should be the appropriate hash value using which this bar should be crossed. So this bar should be my code should be above this bar, because in that case I will win, and those transactions will be called as a valid transactions. So whosoever mine that particular block or find that appropriate nonce value corresponding to which this bar can be set it out, so he will be the miner, he will be the winner, sorry, and that miner will give, that miner will be rewarded with some finite number of Bitcoin. So I mean to say this is a cryptographic puzzle problem, that what should be the appropriate nonce value corresponding to which when we apply and add into this data value, and then we will get appropriate code, and that code should be above this threshold value. So whosoever will be able to find out this nonce value, so he will be the winner. And it will be very easy task for us, because once we get that particular code, we will be verified and validate those transactions. So it will be very I mean to say here, cryptographic hash problem is difficult to find, but it is easy to verify, because let's say we set out certain condition that all those transactions whose leading zeros are, let's say 40, they are valid transactions, and rest of the transactions are invalid transactions. So it will be very easy for us to verify all those transactions whose leading zeros are, let's say 4 zeros. So I hope you understand. And if, but question here arises is that what should be the appropriate nonce value using which we will be able to get it out 4 leading zeros in our code. So whosoever will be able to find out that nonce value corresponding to which we will be able to get out certain codes based upon certain conditions, then in that case that particular we can say miner will be winner. So we can design our own applications using we can say D apps also using blockchain. So we can integrate Ethereum and Ethereum web-based applications, deploy and compile the Solidity codes, and then we can make a GUI applications, and using this GUI D app application we can send out the data to for verification and validations on the Ethereum platform. So this is one of those structures. So it has been used for business to business smart contract design. So I'm giving one of the some of the indicative use cases of we can say blockchain technology. So one of those is smart refrigerators, where we can design our own smart contract which can automatically self get executed. So as soon as user, depending upon user preferences or depending upon user proximity, we will be able to design such smart refrigerator as well. Aircraft maintenance system is also there, where we can design our own smart contract for verification and validations of different assets. So there is no human intervention, it will be required. So automatically we will be able to scan and verify different assets which are used during boarding and lodging of this aircraft maintenance system, right? Then we have enormous number of applications in supply chain management, right? We have digital cryptocurrency, mismanagement of healthcare systems, real estate management, and to name a few. I mean to say enormous number of applications that are associated for uses of blockchain technology, like here digital votings, real estate management, banking, cryptocurrency protection, certification verification, medical record maintenance, asset management. There are a number of applications, online gaming, etc. So those are some sort of indicative applications. So I hope it's time to take some questions if you have any.
Thank you, sir. If anybody is having any question, kindly write on chat window. We will read it for you.
Some question comes. Yeah, some question comes that minimum value for nonce. Yes. So I have already told you that it's all about to decide which particular minimum value. That is the task of the miner. Some task has been given, keeping in view that what should be the appropriate nonce value, keeping in view that that appropriate hash value needs to be choose it out before a particular threshold value. And then some questions comes that what are the challenges in consensus algorithm. So one of those challenges is that how we can design consensus algorithm for quick verification and validations for IoT devices, especially for IoT devices, because nowadays you can see that most of the devices are energy constrained. So POW or POS, as I have already told you, it's energy drain algorithm. So this is one of the crucial issue, that how we can design an efficient algorithm which will be used for quick verification and validations. And that's why DLT, distributed ledger technology, is becoming popular, and IOTA and other algorithms are broadly used for IoT based applications. Then somebody says that blockchain is distributed or centralized. This is completely distributed. We have already discussed it. And then somebody says that how to protect IoT by using blockchain. Protect IoT. I mean to say IoT in the sense that we are talking about data elements. So we have already discussed that a hash algorithm avalanche effect is used for security and privacy preservation in most of the part of the blockchain, because even if a single bit has been changed, so we will get a completely new hash value. So that's why most of the IoT, or irrespective of IoT data, whatever data has been placed on the blockchain is found to be secure. Then consensus algorithm types and which will be good for the fault tolerance. Yes, consensus algorithms are different types of consensus algorithm are there. POW, POS, and other parts, POE. There are an enormous number of consensus based algorithms are there. But to be honest, PBFT has been used for fault tolerance algorithm broadly for making out the fault tolerance as well as consensus algorithm. But the key point for any consensus algorithm, that is that for quick verification and validation, because until and unless verification and validation has not been there, so those transactions cannot become as a part of the blockchain. So PBFT algorithm has been used for fault tolerant part. So I hope I am able to answer all questions. Any other questions? Okay, thank you very
Any
much.
other query? I don't think so, sir. Sir, thank you so much. It was very interesting lecture, and you have made it so simple. Thank you so much for being here and giving your valuable time, sir.
Thank you. Okay, bye.
Thank you, sir.
Thank you all for joining. Thank you very much.
Thank you, sir. Thank you, Neeraj sir.
Bye bye.